discuss the board questions and application questions relating to the chapter wave optics. In the chapter, you have to be very thorough with the following topics: Huygens principle, explanation of reflection and diffraction using Huygens principle, then interference of light and Yinx double slit experiment, and the third one, diffraction of light and single slit experiment. Okay, there are so many board questions and application questions relating to the topics. Now we can see all the formulas relating to the chapter. First one, interference of light. First, bright band. We know the path difference for bright band is n lambda. Phase difference is equal to 2n pi. Distance of bright band from the center of the screen is y equals dn lambda by d. Linear fringe width is beta equals d lambda by d. Angular fringe width is theta equal to lambda by d. Here lambda is the wavelength. Capital D is the distance between coherent source and the screen. Small d is the distance between the two coherent sources. Now for dark band, path difference is 2n plus 1 into lambda by 2. Phase difference is 2n plus 1 into pi. Distance of dark band from the center of the screen y equal to 2n plus 1 into d lambda by 2d. Linear fringe width is beta equal to d lambda by d, and angular fringe width is theta equal to lambda divided by d. Now for diffraction of light, the condition for secondary maxima, path difference is a theta is 2n plus 1 into lambda by 2. Linear fringe width is beta equal to d lambda by a. Angular fringe width is theta is equal to lambda by a. Distance of secondary maxima from the center of the screen y equal to 2n plus 1 into d lambda by 2a. Here a represents the width of the slit and lambda as usual represents the wavelength of light. And for minima, path difference a theta equal to n lambda. Linear fringe width is beta equal to d lambda by a. Angular fringe width is lambda by a. The distance of minima from the center of the screen is y equal to dn lambda by a. Here also a represents the slit width. Now for central maximum, path difference is a theta, which is equal to 0 because at the center maxima is found, isn't it? So a theta equal to 0, path difference is 0. Linear fringe width is doubled, beta equal to 2d lambda by a. Angular fringe width also get doubled 2 lambda by a. Okay, so these are the formula you have to by heart. Now along with that, in interference, this formula also you have to keep in mind. If A1 and A2 are the amplitudes of the waves, so usually in Yinx double slit experiment, we have taken the amplitude of the two waves are equal. Okay, capital A we have taken. If A1 and A2 are the amplitude of the waves and phi is the phase difference, then resultant intensity at the point of superposition is given by I equals I1 plus I2 plus 2 root I1 I2 cos phi. Here I1 is equal to, we know intensity is equal to amplitude square, isn't it? So what is the amplitude? First wave amplitude is A1. So its intensity is I1 equal to A1 square. Second wave amplitude is A2. Its intensity is A2 square. Now the total intensity, resultant intensity is given by the formula I equals I1 plus I2 plus 2 root I1 I2 cos phi, where phi is the phase difference between the two waves. Okay, so here if the amplitudes are not equal, you have to take the intensity as I1 plus I2 plus 2 root I1 I2 cos phi. So just by heart this formula also. What will be the effect on interference fringes if red light is replaced by blue light? This is a board question. So we have fringe width is given by beta equals d lambda divided by d. What will be the effect on interference fringe means what happens to the fringe width. So fringe width is given by beta equal to d lambda by d. We know wavelength of blue color is less than wavelength of red color. So blue color has minimum wavelength compared to red color. Okay, so if red light is replaced by blue light, if blue light means what happens to wavelength? Wavelength decreases and hence wavelength decreases. If red light is replaced by blue light means wavelength decreases. Wavelength decreases means what happens to fringe width? Fringe width also decreases. So, fringe width corresponding to fringe width due to blue color, blue light is less than fringe width due to red light. Okay, children. So, fringe width decreases. Hence, we can say that when red light is replaced by blue light, wavelength decreases and hence fringe width also decreases. Double slit experiment using monochromatic light of wavelength lambda, the intensity at a point on the screen where the path difference is lambda is k units. What is the intensity of light at a point where the path difference is lambda by 3? So, here wavelength is lambda, path difference is also lambda and the intensity at the point is k units. Okay. What is the intensity of light if the path difference is lambda by 3? So, path difference in the first case, path difference lambda. Path difference is equal to lambda means what is the phase difference? Phase difference is equal to 2 pi by lambda into path difference, no? So, phase difference is 2 pi by lambda into lambda, that is equal to 2 pi. So, in the first case, phase difference is equal to 2 pi. And we have the formula for intensity. In Yinx double slit experiment, intensity is given by 4I0 cos square phi by 2. We have derived this formula. Okay. So, I equal to 4I0 cos square phi by 2, that is the intensity in Yinx double slit experiment. So, it is equal to 4I0 into cos square, what is phi here? 2 pi. So, 2 pi divided by 2 is equal to 4I0, 2 cancel cos pi. Cos pi is -1. -1 the whole square. So, -1 the whole square equals 4I0. Okay. So, this intensity is given by what? This intensity is given by k units. Okay. So, if phase difference is 2 pi, path difference is lambda, phase difference is 2 pi. Now, the intensity is given by k. Okay. So, 4I0 is equal to k, that is given. Okay, children. Now, in the second case, what is the path difference? Path difference is equal to lambda by 3. What is the phase difference? Phase difference is equal to 2 pi by lambda into lambda by 3. Okay. So, it is equal to 2 pi by 3. So, if path difference is lambda by 3, phase difference is equal to 2 pi by 3. Now, we have to find out the intensity. In this case, we have to find out intensity. That is the question. So, using the same formula, I equals 4I0 cos square phi divided by 2 is equal to 4I0 cos square. What is phi here? We got phi as 2 pi by 3. 2 pi by 3 by 2. Okay. So, into 2. So, 4I0 into cos square pi by 3. Pi by 3 means cos pi by 3 cos 60. Cos 60 it is 1 by 2. 1 by 2 the whole square, that is 1 by 4. So, we got the answer as I0. Okay. The new intensity is I0. So, in the first case, if path difference is lambda, what is the phase difference? 2 pi, then the intensity 4I0 is k. So, what is I0 from this one? K by 4. So, we have 4I0 is equal to k, no? So, what is I0? K by 4. So, in this case, in the final case, when path difference is equal to lambda by 3, what is the new intensity? We got the new intensity I equal to I0, isn't it? So, that is equal to k by 4. So, we have to find out the answer in terms of k, because in the first case intensity is given by k, no? So, in the last case, second case intensity is also given by k divided by 4. Is it clear, children? So, here if a path difference is equal to lambda by 3, phase difference is equal to 2 pi by 3, we got the answer of intensity is I0. Okay. But in the first case, we got I0 is equal to k by 4. So, using that formula, we can write intensity I, the new intensity I equal to I0 equal to k divided by 4. That is answer. In Yinx double slit experiment, the two slits are 2 mm apart and the screen is at 140 cm away from the slits. The slits are illuminated with light of wavelength 600 nanometer. Find the distance of the third bright fringe from the center. If the wavelength of light were changed to 480 nanometer, find the shift in the position of the third bright fringe from the center. Okay, so first wavelength is 600 nanometer. Okay, 600 nanometer, we have to find out the distance of the third bright fringe. So what are the values given? Here given lambda first case. Okay, first case lambda is equal to 600 nanometer, we can convert to meter. Then two slits are 2 millimeter apart. So small d is equal to 2 millimeter. Then the screen is at 140 centimeter. So capital D is equal to 140 into 10 raised to minus 2 meter. We have to find out the distance of the third bright fringe. So distance of third bright fringe is given by y equals dn lambda divided by d. Okay. So third bright fringe. So y equal to n equal to 3. Here n equal to 3. No, third bright fringe means we have to put n equal to 3. We can substitute 3 into what is d, 140 into 10 raised to minus 2 into lambda 600 into 10 raised to minus 9 divided by small d is 2 into 10 raised to minus 3, and after simplification you will get the answer as 1.26 into 10 raised to minus 3 meter. Okay. Now the second case is if the wavelength is changed to 480 nanometer. Okay, wavelength changes to 480 nanometer, we have to find out the position of the third bright fringe. So second case, what is the wavelength lambda? 480 nanometer. No other values changes. Okay, so here also position of the bright fringe is dn lambda by d. Third bright fringe, so n equal to 3. Here we can find out y. Y is equal to d remains same, 140 into 10 raised to minus 2 into small n is 3. Lambda is 480 nanometer into 10 raised to minus 9. Small d is 2 millimeter, 2 into 10 raised to minus 3. Okay, and after simplification you will get the answer as 1.01 into 10 raised to minus 3 meter. So position of the third bright fringe when lambda is 480 nanometer is 1.01 into 10 raised to minus 3, and the position of the third bright fringe when lambda is 600 nanometer is 1.26 into 10 raised to minus 3. Here the question, find the shift in the position. Okay, find the shift. So shift in position, change in position is equal to 1.26 into 10 raised to minus 3. We can subtract 1.26 into 10 raised to minus 3 minus 1.01 into 10 raised to minus 3. So it is equal to 0.25 into 10 raised to minus 3 meter. So the position changes by 0.25 into 10 raised to minus 3 meter. What is the shape of wavefront in each of the following cases? Number 1, light diverging from point light source. Number 2, portion of wavefront of light from distant star intercepted by Earth. Light emerging out of a convex lens when object light source is placed at its focus. First one, light diverging from point source. We know that around the point source wavefronts are always spherical. So first one like this, spherical wavefront. No need to draw the figure, just you have to write the answer. So second one, portion of wavefront of light from distant star intercepted by Earth. So we know that if a star is at infinity, around that star wavefronts are always spherical. Around that star wavefronts are spherical. But when it reaches the Earth, it becomes a plane wavefront. Okay. So here the star is at infinity, wavefront reaches the Earth, becomes plane. That is the second one. Third one, light emerging out of a convex lens when object's light source is placed at the focus. For example, like this. So this is the convex lens. If an object light source is placed at its focus, so here is the focus. Okay, so here if an object light source is placed here, what about the wavefronts around it? They are spherical wavefront. So object is at the focus. Where is the image formed? Image is formed at infinity. Okay, so here object is at the focus means image is formed at infinity. So what is the shape of the emergent wavefront? They are always plane wavefront like this. Because here is the object, this is object light source, around it wavefronts are always spherical. But we know that when object is at the focus, where is the image formed? Image is formed at infinity. And for an infinite source, what is the shape of the wavefront? They are always plane. So this represents the plane wavefront. So here the answer, light emerging out of a convex lens when object's light source is placed at the focus, the answer is plane wavefront. And in the theory portion we have studied, if plane wavefront is incident, what is the emergent wavefront? It is spherical. Okay, so if plane wavefront is incident means emergent will be spherical, and if spherical wavefront is incident, emergent will be plane wavefront. So the third one answer is plane wavefront. The intensity of light at a point on the screen in Yinx double slit experiment where the interfering waves of equal intensity have a path difference of lambda by 4. So two waves have equal intensity and the path difference is number 1 lambda by 4 and number 2 lambda by 3. We have to find out the intensity of light. Okay, so if both the waves have same intensity, the total intensity, resultant intensity is given by 4I0 cos square phi by 2. Okay, so I0 is the intensity of each wave and I represents the total intensity, phi is called phase difference, that you know. So I equal to 4I0 cos square phi by 2. This is the intensity of light on the screen in Yinx double slit experiment. Okay, so first case, what is the path difference? Path difference is equal to lambda by 4. If path difference is equal to lambda by 4, what is the phase difference? Phase difference is equal to 2 pi by lambda into lambda by 4. So the answer is pi divided by 2, pi by 2. Okay, phase difference is pi by 2. We can directly substitute, therefore I becomes 4I0 into cos square phi by 2. But what is phi? Pi by 2. Okay, phase difference is phi. Phi is equal to pi by 2. So here it is pi divided by 4. Phi is equal to pi by 2 divided by 2. So it becomes pi by 4 is equal to, what is cos pi by 4? Cos pi by 4 is equal to 1 by root 2. Isn't it, children? So here the answer is 4I0 into 1 by root 2 the whole square, that is 1 by 2. So it is equal to 2I0. I0 is the intensity of each wave. Now the total intensity is given by 2I0. Now the second case, path difference is equal to what? Lambda by 3. Path difference is lambda by 3. What is the phase difference? Phase difference is equal to 2 pi by lambda into lambda by 3. Okay, so the answer is, it is equal to 2 pi divided by 3. Phase difference phi equal to 2 pi by 3. Again we have intensity I equals 4I0 cos square phi by 2. So it is equal to 4I0 cos square phi equal to 2 pi by 3, no? So 2 pi by 3 into this denominator 2. So it is equal to 4I0 cos square pi by 3. And we know cos pi by 3 is equal to, what is cos pi by 3? Cos pi by 3 is equal to 1 by 2, half. Cos 60 degrees 1 by 2. So it is equal to 4I0 into 1 by 2 the whole square, no? So it is equal to 4I0. 4I0 into 1 by 4, that is equal to I0. Okay, so when path difference is lambda by 4, intensity is 2I0. When path difference is lambda by 3, intensity is I0. Another very important question. Two monochromatic light beams of intensities I and 4I superimpose. Find the maximum and minimum possible intensities in the resulting beam. Okay, so two beams having intensities I and 4I, when they superimpose, find the maximum intensity and the minimum intensity. And we have the formula for intensity. Here they have different intensities, no? So two light waves have different intensities, I and 4I. If they have the same intensity, we can use the formula. The resulting intensity is 4I0 cos square phi by 2. Okay, cos square phi divided by 2. But here the intensities are different. If intensities are different, we have the formula I1 plus I2 plus 2 root I1 I2 cos phi. This is the general formula for intensities. Here I1 and I2 are the individual intensities. I represents the resulting intensity and the phi represents the phase difference. Okay, so here we have to find out the maximum and the minimum intensity. Intensity is maximum intensity. For maximum intensity, what is the value of phi? The phase difference phi is equal to 0. Okay, for minimum intensity, what is the value of phi? For minimum intensity, phi should be minimum. Minimum value is 180 degree. Cos, no? So minimum value is 180 degree. So intensity is maximum when the phase difference is 0 and intensity is minimum when phase difference is 180 degree. So we can write the maximum intensity as I1. What is I1 given? I. I2 can be taken as 4I. Okay, so two intensities are I and 4I. Here I and 4I. So here we can write I1 is I, I2 is equal to 4I plus 2 into root of I into 4I cos 0. Cos 0 is 1. So it is equal to 4 plus 4I plus 4I, that is 5I, plus here it becomes 2 root of 4I square, no? So it is 2I, cos 0 is 1. So it is equal to 5I plus 4I equal to 9I. So the maximum intensity is equal to 9I. And the minimum intensity is equal to same formula we can use I1 plus I2, that is I plus 4I plus 2 into root of I into 4I. Here theta is 180 degree, no? Cos 180. Cos 180 is minus 1. So here we can write I plus 4I, which is 5I. Here cos 180 minus 1, that minus can be taken here, minus 2 into root of 4I square, no? So it becomes 2I. So it is equal to 5I minus 4I, which is equal to I. So maximum intensity is 9I and minimum intensity is I. Okay, so by heart the formula, if the different intensities are given, we can use the formula I equal to I1 plus I2 plus 2 I1 I2 cos phi. Phi is the phase difference between the two waves, and intensity is maximum if you take phi is equal to 0, and intensity is minimum if phi equal to 180 degree. Now we move on to next question. Two slits are made 1 millimeter apart and the screen is placed 1 meter away. What should be the width of each slit be to obtain 10 maxima of double slit pattern within the central maxima of single slit pattern? Okay, so once more, two slits are made 1 millimeter apart. Two slits are made 1 millimeter apart means the distance between the two slits is D equal to 1 millimeter. Okay, two slits means it is indifference. And the screen is placed 1 meter away. The distance between slit and the screen is given by capital D. It is 1 meter. Question is, what should be the width of each slit be to obtain 10 maxima of double slit pattern within the central maxima of the single slit? Okay, single slit is diffraction pattern. Double slit means to obtain the interference pattern. So within the central maximum, so this is the central maximum. The central maximum consists of how many maxima? How many maxima means how many bright fringe? It consists of how many bright fringe? 10 bright fringe like this. It consists of 10 bright fringe. Okay, so in the central maximum it consists of 10 bright fringes. Now if the central maximum consists of 10 bright fringes, we have to find out the width of the single slit. Okay children, so from the question we can write what is the width of each bright fringe. In the case of interference pattern, the width of each bright fringe is width of each bright fringe. Bright fringe and dark fringe remain same in the case of interference. Width of each bright fringe is d lambda by d. Okay. So, how many such bright fringes are contained in the central maximum? 10 bright fringes are there, isn't it? So, width of the central maximum. What is the width of the central maximum? We know the width of the central maximum is equal to 2d lambda by A. A represents the width of the single slit. Small d represents the distance between the two slits. Okay, children. So, width of the central maximum is 2d lambda divided by A, and the width of each bright fringe is beta equal to d lambda by d. So, in the question 10 bright fringes means 10 d lambda by d are included in the central maximum, isn't it? 10 bright fringes are included in the central maximum. So, 10 bright fringes means 10 into width of the bright fringe d lambda by d. It is included in the central maximum, which is 2d lambda by A. Lambda get cancelled, d can get cancelled. So, d get cancelled, lambda also get cancelled. So, we can write 10 by d equal to 2 by A. Here what is d given? D is equal to 1 millimeter. Okay. So, 10 divided by 1 millimeter, we can convert to meter, is equal to 2 divided by A, and we can write A is equal to 2 into 10 raised to minus 3 divided by 10, that is 0.2 into 10 raised to minus 3 meter. So, width of the single slit is given by 0.2 into 10 raised to minus 3 meter. Okay. We move on to 8th question. In a single slit diffraction experiment, a slit of width d is illuminated by a light of wavelength 650 nanometer. For what value of d will the first minimum fall at an angle of diffraction 30 degree, the first maximum fall at an angle of diffraction 30 degree. Okay. So, here we have to find out the slit width d. Here slit width is represented by d. We have to find out d. Okay. So, d slit width d equal to question mark. Angle of diffraction is given as 30 degree. Okay, children. Now, wavelength is also given 650 nanometer, 650 into 10 raised to minus 9 meter. So, these are the values given. Now, first minimum, we have the condition for first minimum. We have the condition for minima. The condition for minima is path difference. What is the path difference? Path difference is A sin theta. That is A sin theta. If theta is very small, we can take A sin theta is approximately equal to theta. But here theta is given as 30 degree. In that case, we have to take A sin theta. Okay, children. If angle is given as in degree, then we have to take A sin theta. Theta is not small here. So, if theta is small, very small degree, very small angle, then only we can take sin theta is approximately equal to theta. But here theta is given, it is not small, therefore we have to take the original formula A sin theta, that is the path difference. A sin theta equals minima, condition is n lambda, the condition for minima. But here what is A? The slit width is given as D. Okay, so here we can write, so here A is equal to D, no? So, D sin theta is equal to n lambda. Slit width is given by D here. Okay. So, D sin theta equal to n lambda. That is a condition for minima. Here first minima means we have to put n equal to 1. So, put first answer, put n equal to 1. We can write D sin theta is equal to 1 lambda. That is D we have to find out, no? So, D into sin 30 is equal to lambda, or D is equal to lambda divided by sin 30. What is lambda given here? 650 nanometer. 650 into 10 raised to minus 9 divided by sin 30 is 1 by 2. Okay. So, 2 comes to the numerator, 650 into 2 into 10 raised to minus 9, and the answer is 1300 into 10 raised to minus 9 meter. Okay. Now, the second one. Second one is the first maximum fall at an angle of 30 degree. The condition for maximum, we have the condition for maximum is A sin theta. Here also angle is given, no? So we can take the direct formula. A sin theta is 2n plus 1 into lambda by 2. That's the condition for maximum. Here also first maximum, no? Therefore n is equal to 1. So here we can write A sin theta, put n equal to 1, that is 3 lambda by 2. Here again A is equal to D. Here also A is equal to D. Therefore here we can write D sin theta. Here also we can put D sin theta. Okay. So D can be written as 3 lambda divided by 2 into sin theta. What is theta here? Here also 30 degree. Okay. So it is equal to 3 lambda divided by 2 into sin 30 is 1 by 2. So it is equal to 3 lambda. That is 3 into, here also lambda is 650 into 10 raised to minus 9. And the answer is 1950 into 10 raised to minus 9 meter. Okay, so just keep in this mind, if angle is given, you have to take angle is 30 degree or 60 degree, or some angle is given, you have to take sin theta. If angle is very small, then just take a theta. Okay children.